Okay, so before we do a full example of a two sample proportion comparison test, what I'd like to do is just show you how you would enter in NumWorks all of the data. Okay, so let's say we have two populations, population one, population two. We take a sample of 389 from population one, and we have 219 successes. And what that means is that N1 is 389, and X1, number of successes, is 219. So X1 is 219. And so the way we would identify P1 hat is we would do 219 divided by 389. So 219 divided by 389, which we could, we can go into the calculator and let's see, 219, 389, we can do 219 divided by 389, and we would get 0.562982, 562,982. 0.562,982. Okay, so that would be our P1 hat. But I want to show you how you can actually get this information out of the NumWorks calculator in another way. Let's look at our population 2. Our sample size is 610, so N2 is 610, and then X2 is 315. And in this test, we're doing a two-tail test, and alpha is 0.04. Now, since alpha is 0.04, our confidence level is going to be 0.96. Okay. Now, the reason our confidence level is 0.96 is because it's a two-tail test. But if we had a right-tail test, we'd have to double this, and then it would be 0.92. Okay, but let's get to that in a bit. Okay. All right, so what we're going to do is we're going to go to the NumWorks calculator, and we're going to go down to, we've seen this previously, we're going to go into inference, and we're going to go into tests, and we're going to select two proportions. There we go. And when we get in here, we have to select our null hypothesis. So if it's a two-tailed test, we're going to choose this. We're going to choose you can see there's three. There's greater than, not equal to, or less than. We're not going to use the less than. That's the left tail test. So we're only going to use the greater than and the not equal to. Since this is a two-tailed test, we're going to select not equal to. So okay, so we're going to go down to next, then okay. Now it's just going to ask us for X1 and N1 and X2 and N2. So X1 is 219, so we're going to put in 219, enter. N1 is 389, 389, enter. X2 is 315, 315, enter. And N2 is 610, 610. And then it says the significance level, and it's 0.04. And now we're going to hit next. And look, here's our P1, 0.562,982, 0.562,982. And so now for our P2, it's just right here. It's 0.516393. So if we said, okay, well, what's P2 hat? P2 hat, it's just 0.561393. 0.561393. Okay, great. And then the pooled proportion right here is 0.534. So P star is 0.534, 0.534, 535. And so let's see if there's anything else that we can find in here. Oh, look, there's the z-test statistic. Look, remember, I mean, it's terrible. It's that difference over square root. Well, there's the z-test statistic right there. So we already know the z is 1.439, 477, 477. All right, and let's see if there's anything else. Oh, there's the p-value. Wow, our p-value is right there, 0.1500. 0.150016. Okay. Now this is really great because there's something that I didn't mention yet, which I was going to mention, and that is when you do the p-value, if you get the p-value out of here, let's see. So if we put in this z-test statistic, if we go to the distributions, hit OK and go down to, this is a z-test, so it's a normal distribution. So if we go to the right tail test, because that's how we get the p-value, and then put the z-statistic in here, which is 1.439, 1.439, 477, 477. Look, it says the p-value is 0.0750771. So why is it 0.075 instead of 0.15? Well, it's a two-tailed test. Remember, write this down. Remember, with a two-tail test, you have to double the p-value. You have to double the p-value. So we have to double this. We have to do this number times 2. I don't know if you remember that or not. We have to do 0.075 times 2. Well, that would give us 0.15. So what this is saying, what I'm saying here is that this is already doubled. This p-value right here. This p-value has already been doubled. The calculator already knows it's a two-tailed test. How does it know it's a two-tailed test? Because back here you told it was a two-tailed test. You picked the not equal to. This means it's a two-tailed test. So then when we came over here, it knows it's a two-tailed test, and that's why it gave a p-value. It already doubled the p-value. Well, what would happen if we told it was a one-tailed test? Well, if we told it was a one-tailed test, if we did this instead and had all the same numbers, look, the p-value is now 0.075, just like we just saw in here, 0.075. So if you get the p-value from here, from this place, from distributions, and it's a two-tailed test, you have to double the p-value. But if you get the p-value from, if you tell the inference here that it's a two-tailed test, and you get it from in here, then you don't have to double the p-value. They've already doubled the p-value, okay? And I think that that's it. If you hit next, all it does is it shows you the test here, and it shows you the p-value, puts it in. See, it's a two-tailed test, so it puts it in both tails, all right? So now we can also go to inference. Watch this. And now if we go to intervals and hit OK, whoops, let's go back, and go to two proportions, okay? Once again, we're going to put all the information in. We're going to put x1 is 219, n1 is 389, x2 is 315, n2 is 610. Confidence level, I told you, confidence level is 0.96. So we're going to put in 0.96. And then next. And look, it gives us P1 minus P2, the difference. And look, it gives us Z star. So now we have Z star. Oops. Z star is 2.053. .053, 749, and look, it gives us the standard error. Standard error is 0.0322, 78. And then there's one more thing, I think. Oh, there's the margin of error. That's the Z critical times the standard error. And then if we hit next, look, it even gives us the interval. Here's our interval, -0.0197024 and 0.11288. So this number and this number, that's our confidence interval. So we would write that somewhere. I don't know, let's scroll down maybe. And what we would say is that P1 minus P2, and then we have the less than or equal to here, and the less than or equal to here, and we'll put negative 0.019, negative 0.019, 702, 702, and then over here we'll put this number, 0.11288, 0.11288. And you can see that 0 is on the interval. We have a negative number here and a positive number here, and 0 is on the interval. And when 0 is on the interval, we do not reject. We do not reject H sub O. And look, the p-value here is larger than 0.04, so we do not reject. And look here. The z statistic, 1.439, is not larger than the critical z statistic, 2.053. So again, we do not reject. And we did all of that without using a single formula. All we did was go into the NumWorks and we used the inference feature. We put some information in tests and we put some information into intervals. And so if we use both of these things within the inference feature, then we'll get everything that we need. Okay, now that we see that, why don't we do an example? All right, let's look at this example. It says independent random samples, each containing 70 observations. Okay, so each containing 70 observations were selected from 2 populations. So sample sizes of 70, 2 of them. So basically what that means is that N1 is 70 and N2 is also 70. It's saying that both populations each contain 70 observations. The sample from population 1 resulted in 45 successes. So X1 is 45. And then the sample from population 2 resulted in 26 successes. So X2 is 26. And it says test the null hypothesis that P is equal to P1 is equal to P2 against the alternative hypothesis that they're not equal. So that's a two-tailed test. This is a two-tailed test. How do I know? Because it says not equal to. Okay, it says use alpha equals 0.06. So the level of significance is 0.06. We can write that here. Alpha equals 0.06. And then we'll make our statement reject H sub O if P is less than 0.06. I think I forgot to give this instruction when I went through the steps, so make sure that you're making this statement to reject H sub O if the p-value is less than the alpha. Okay. Okay, so that's step 1, or that's really step 2. Sorry, step 1 is stating the null and alternative hypotheses. I forgot to do that. So step 1 is H sub O, but I mean they're kind of already stated up here, but let's go ahead and state them. P1 is equal to P2, and then alternative hypothesis is that P1 is not equal to P2, right? So here's the null equals each other. Here's the alternative not equal to each other, okay? All right, in step 3, we're supposed to identify the Z star, the Z critical, and then make a statement, a rejection statement. So why don't we go ahead into the NumWorks calculator, and the Z star is found in inference and it's found in intervals. Okay, so we're going to go in here, we're going to go to 2 proportions, and X1, let's see, X1 is 45. Okay, so we'll put in 45. And then N1 is 70. And then X2 is 26. and N2 is also 70, 70, okay? And then the confidence level. Well, if the alpha is 0.06, the confidence level is equal to 1 minus alpha. Now that's only for a two-tail test, okay? If it's a right tail test, then it's actually 1 minus, and you know this, you've seen this, 1 minus 2 alpha. I described this when I explained the one sample hypothesis test. I showed that if you want the confidence level that you have to do, if it's a right tail test, you have to do 1 minus 2 alpha. But if it's a two tail test, you just do 1 minus alpha. So here our confidence level is 0.94 or 94%. Okay, so we're going to put in 0.94, execute, we're going to go down and next. Okay, and look, here's our Z critical. Our Z critical is 1.88. 079, 1.880794. So 1.88074. Well, that was easy. So now we're going to say reject H sub O if Z, the actual statistic, is greater than 1.88074. All right, that's step 3. Now step 4, we want the standard error and the Z test statistic. Okay, so we're going to go in the NumWorks calculator to do that. We don't want to use intervals, we want to use tests. We'll hit OK, go down to 2 proportions, hit OK. Our null hypothesis is equals 0. Our alternative is not equal to 0. Well, it's P1 is not equal to P2. But if they're not equal to each other, then P1 minus P2 is also not going to be equal to 0. So it's saying the same thing. So then we go to next. Okay. And so X1 is 45. And N1 is 70. And X2 is 26. And N2 is also 70. Now it wants the significance level. Significance level is 0.06. So 0.06. And then next, and look, we have a bunch of information here. We were supposed to identify the P1 hat and the P2 hat and the pooled proportion back in step 2. So now we can actually do that. We can now say that P1 hat is 0.642, 857. We can also identify P2 hat. P2 hat is 0.371, 429. And then we can also identify our P star, which is the pooled proportion, 0.507, 143. Good. All right, so we've got those 3. And now look, there's the Z test statistic. So Z is equal to 3.211, 914. And now we need our standard error. Now standard error, we don't get that from here. Oh, there's our p-value. Let's go ahead and put that for step 5. Step 5, we're going to want our p-value. And P is 0.0013, 0.0013, Okay, now we got to go back to back to the interval feature here to get our standard error. Maybe we should have gotten it before. 2 proportions, and look, we have to put the numbers in again. It didn't remember them. So X1 is 45, N1 is 70. X2 is 26, N2 is 70 again. Our confidence level was 0.94. There we go. And now we'll hit next. And here's our standard error, 0.08. Let's go down. There we go, 0.081334. 0.081334, okay? And now this is our p-value, and since this p, look, if p is less than 0.06, this is definitely less than 0.06, it's 0.0013, so that's less than 0.06, so we're going to reject H sub O since, okay, our p-value is less than 0.06 and our z statistic 3.211,914 is greater than 1.880794, is greater than 1.880794. Okay, so because of both of these reasons, we're going to reject the null hypothesis. And now we're going to move on to the confidence interval. So step 6, confidence interval, and we're in the right place for that. It's if we go down here and then go here to next. Look, here's our 94% confidence interval, 0.118457, 0.118457, less than or equal to P1 minus P2, less than or equal to 0.4244, 0.4244. And look, we have a positive number here and a positive number here. So 0 is not on the interval. And when 0 is not on the interval, we reject H sub O, which is what we said over here. And therefore, we are done with this example.